Okay, so we're going to do what's called dividing radical expressions. And when we divide radical expressions, it's the same thing as rationalizing the denominator. So when I say rationalize the denominator, you're basically dividing radical expressions. So 1 second. All right. So let's make this nice and large. Okay, so this is the first situation that I'm going to do. There's two scenarios that can happen. So first, we're going to talk about rationalizing, right, which is dividing radical expressions. And we'll start with square root stuff. Now, you're going to see what's going to happen. So let's just make something up here. 2 over the square root of 5, something simple like that. Rationalizing the denominator, or dividing radical expressions, which is what this is, 2 divided by the square root of 5. You have a fraction or division, including radicals, which is what I have. You really just want to get the radical expression from the bottom of the denominator, from the denominator. And if you think about square root, let's recall, like if I'm taking the square root of something, I want to create a perfect square. And in one of my videos, I did show that if I have the exponent on, let's say, some base matching the index of the radical, they kind of cancel each other out and it just simplifies into the base. So if I want to get rid of this radical sign on the bottom of this fraction, then I want to create the amount of 5s in this case that match the index. So I have, in other words, I have 1 5 under here. So that means I'm going to need another 5. And I can only multiply 2 radical expressions if they have the same index, right? Which in this case is 2. But whatever I do to the bottom of a fraction, I also have to do to the top. So what I'm doing here is I am multiplying the bottom of the top of this fraction by the square root of 5. And what that's going to create is, and I'm going to show my work for the first one. I'm not always going to show this part of it, and you'll see what I mean. I'm going to get 2 times the square root of 5 on top. I cannot multiply the 2 and the 5 because one is outside and one is inside, but these can be multiplied. And what I'm going to do is write it like this, because it'll help you when you deal with indexes. That's not the proper verb, but word. But I want to show that this matches the index so that they cancel each other out. And I just get 5 on the bottom. So the square root of something times the square root of itself is basically itself. Or, the square root of 5 times the square root of 5 is the square root of 25, which is 5. Most of the time, I'm not going to show this until we get into more complicated situations. On the top, I have 2 times the square root of 5. On the bottom, I have just 5. And now this is my rationalized fraction. So this is example 1, nice and easy. If I have a square root, and I'll start with square roots examples, and then I'll go into other ones, maybe in another video. Let's do 2 times the square root of 3 over, I'm going to pull variables in here. Let's do 7x under the square root, and I want to rationalize. So again, I want to rationalize, which means that I want to clear out the radical form or the radical sign in the denominator, which is the same thing as dividing the radical expressions. And again, my index is a 2. So that means I'm going to need, 7 squared and x squared to cancel. So I'm going to multiply the denominator by the square root of 7x. That's going to create in the denominator the square root of 7 squared times x squared, because 7 times 7 is 7 squared. Excuse me, and x times x is x squared. And I'm showing it this way because of the fact that when it gets a little bit more complicated, that might help you. Whatever I do to the bottom, I have to do to the top. Oh, I should have gone back to my white here. And so the thing is here, I have a 2 outside, and there's nothing to multiply the 2 by because nothing else is outside the radical. So that stays out. But I have a square root of 3 and a square root of 7x. And based on your properties and your rules of multiplication of radical expressions, I can multiply the 7 and the 3 and get 21x underneath the radical on top. Now I will have to think about whether or not 21 can be simplified or the square root of 21 can be simplified, or can this be simplified anymore based on our rules that we did before. And this is multiplication. Can I simplify the bottom? Because I don't want to leave it in an unsimplified form. So I can't simplify the top anymore, but the bottom can be simplified because this can cancel, and I'll just simplify to 7 and an x, which is what we wanted. We wanted to clear out the radical sign in the denominator, and now I have rationalized this particular radical expression, which is also a fraction with a radical sign on the bottom. So these were just square root scenarios. You know, you want to create pairs. You want to create something squared so that it cancels with the radical sign and the index, which is a 2 for a square root. But what